Hello, my name is Rob Reynolds. Welcome to Calculus Section 4.4. Today we're going to learn how to optimize functions, reading a problem. And our first one says we've got a corral and one of the sides shares a barn, and there's other constraints. 3 exterior fences and 2 interiors. So I'll make 3 exteriors, 1, 2, and 3. And we've got a couple interiors, and it forms a rectangle. So when you're doing your test, it's really important for you to define your variables for me clearly. I'm going to call these x's. You might call them y's, and then I'm going to call this distance y, and you might call that an x, or you might even call that a length and a width. So that's why it's important for you to define your variables. So the next thing I want to do after you kind of draw a picture and have it labeled, I want to look for an equation. And I noticed up here we're trying to maximize the area, so I'm going to talk about the area of this rectangle is xy, length times width. And I also noticed that I've got 400 feet of fencing, so I could write all of this red, which is my 4x's plus a y has to equal 400. So in this case, I actually need to write 2 equations. This is my perimeter, and then this is my area function, and I think I can solve for y down here and do a quick substitution. I'm going to plug that in right here. That will give me x times my new y, 400 minus 4x, and now I can maximize the area by taking the derivative. So a prime x is equal to 400 minus 8x. And as we've learned in the previous sections, if we set that equal to 0 and solve for x, we'll get a maximum value. And if the max happens when x is 50, if I want to find the y value, I can do a quick substitution right in here. Y is 400 minus 4 times the 50. And that will give me y is equal to 200. So now I've got x and y, and I can find the area if by taking the length times the width, 50 times 200, and end up with the max area of 10,000. So here's how the author worked it out. Again, x is 50, y is 200, and the max is 10,000 square feet. You could have also just graphed the function and guess left, guess right, guess on, but in this case, remember, you need to demonstrate your calculus, how to take the derivative set equal to 0 to find the maximum. This next problem talks about a box or a bag going onto an airline, and it's in a box shape, but we don't know if it's a square box or a rectangular box, but we do have some dimension restrictions. So I'll draw a box, and we'll talk about the length and the width not exceeding 64. It does say it has a square base, so instead of doing length times width times height, I suppose I could make this width the same as the length. So I've got 2 L's and a height. In fact, there's my volume formula. It looks like I'm going to be writing a couple equations again. So the volume would be length squared times the height. And a second equation is here in yellow. It says the sum of all of these dimensions. So I've got 2 L's and a height cannot exceed 64. Which means my height is 64 minus 2L, and there's my substitution. So our new equation is L squared times 64 minus 2L. Now you may ask, why didn't I solve for this L? Well, it was harder, but plus, and you could have mathematically, but after I solved for that L, I would have had to square that quantity. So kind of think about which variable might be a little bit easier to solve for. 64L squared. There's 2L cubed. I'm going to maximize this to find the maximum length. Taking the derivative and setting it equal to 0. I think I can factor out, well, at least a 2. And set that equal to 0. That's not nice. Let's just leave it 64 thirds. So the length is 64 thirds. And to find the height, I'll plug it in here. And I don't think that's going to be nice at all either. So I'll grab a calculator, punch it in, hit math, enter, enter, and that kind of makes sense. The length is 64 thirds, the height is 64 thirds, and again, we knew it had a square base, but we didn't know the box itself was a square, but that kind of makes sense. For maximum area, you will make it a square. That's going to give you the best possible volume. So speaking of the max volume, I will go and plug this in for my volume. Let's plug that 64 thirds in for that length. Squared minus 2 times the 64 thirds cubed, and find out what that max volume is. And I think that turns out to be around 9,709. Inches cubed, yep. And 64 thirds and 64 thirds for the dimensions. And again, here's the graph. So you can see that, again, you could have just graphed the function, guess left, guess right, guess on, but the point of this is to demonstrate your content knowledge of finding the function. Instead of graphing it and finding the max, take the derivative and set it equal to 0. So again, you need to demonstrate that. It's not the answer I'm looking for. It's you taking the derivative and set it equal to 0 to find the max. The next example, well, these are the guidelines that the book lays out for you, but write a couple equations. Identifying any variables and then eliminate one of the variables. Remember, that's doing that substitution method. And then find the maximum by using calculus. So don't use your calculator here. So yeah, this one is a great problem. Just for the sake of the video, I'm going to skip it. I would read through here. There will be none of this on the quiz or the test, but it is a great problem that starts talking a little bit about the cosine of a half angle. I'm trying to remind you a little bit about trig. So that's a good problem. This next problem, we're going to be using similar triangles, which is a technique that I haven't shown you very often, but it happens quite a bit, especially when I deal with a cone. Just to remind you, this problem doesn't have a cone in it, but we'll get to these problems where you have a triangle down here of a small radius, and then you have a larger radius here, and you can see similar triangles here. And so we'll set up some ratios. R sub 1 of the red is to this height, as the blue R sub 2 is to its smaller. There's H sub 2 down there. So we can start setting up ratios. Let me show you what I mean. In this case, we have a house and a ladder that's extended to the house, and it's over an 8-foot tall fence. And so I have a fence, and it's parallel to the house 3 feet away. So there's parallel to the house. So let's label this house. We got this height here. We don't know what that how high the ladder is, and we have this unknown value here of x. So all of a sudden I can see some right triangles, some similar right triangles. Here's that red triangle, so I could say 8 is to x, and then I have a blue triangle, and I could say, let's see, since 8 is the height, then I'll say height is to this total distance, which I'll call x plus 3. So I could solve for h using cross multiplication, and I could actually solve for height. So there's one formula. Another equation talks about the relationships of the sides of the triangle, and I could use SOHCAHTOA if I was looking for angles, and I'll show that to you later, but in this case I think I want to use the Pythagorean theorem. A squared plus b squared equals c squared. Now let's see, so I don't have a variable for the length of the ladder, so I'll just let that be L, and down here it will be L squared. So there's another second formula, and I've got my height that I can plug in here. And so this is going to get a little mathematically challenging. X squared plus 6x plus 9 plus, and then I'm going to multiply this out, combine like terms, distribute. So the rest of this is kind of just a number crunching exercise. Let's see if I can do some of it real quick here for you before we take the derivative of this thing. I'm just going to multiply it out. There might be an easier way to factor out. But most of us feel comfortable multiplying things out before we take the derivative. So I'm going to divide each term by x squared. So when I distribute this and divide by x squared, I just get 64 plus 384x divided by x squared is x to the negative first. And 64 times the 9 is the 576. And then I've got divided by x squared, but I'll bring that up top so it's easier for me to take the derivative of. Now over here, when you take the derivative of L squared, remember L is the length of the ladder, which is a constant. It's not changing, and the derivative of a constant is always 0. And the derivative of this constant will be 0 too. So 2x plus 6 for the derivative minus 384x to the negative second. Whew. Minus 1152x to the negative third. So I think the next thing that I would do is clear these negative exponents by multiplying both sides by x cubed. So 2x to the fourth plus 6x cubed minus 384x minus 152 equals 0. Then I'd pull out my graphing calculator, graph this thing, hit zoom 6, and solve because I don't want to factor that thing. And then I think if you guess left, guess right, guess on, it's going to be close to 5 points. Let's do it. So I can just show you. I'll calculate the zeros at 2 and 8, and I'll guess 5. So it's really close. Let's go 5.77. X is around 5.77. And I'm going to take that 5.77 and plug it back in to my H formula. So I get 8, 5.77 plus 3 over 5.77 is my height. And if you punch that, your height will be really close to 12.16. Sorry, my pen. And then I would take this height and the x and plug it back into here. 5.77 plus 3 quantity squared plus 12.16 squared is L squared. This will turn out to be around 224.7785. And then if I take the square root of that, I'll get the length around 15, approximately. So let's see, I bet the author did some factoring trick here. So they got, yeah, so they didn't multiply it out. And that might have been an easier route. I see an x plus 3 and an x plus 3 that quantity square that they factored out. Oh my gosh, that's a lot easier. And then, well, I don't know. And then, but to take the derivative of this, you'd have to do the product rule. So 1d2 plus 2d1, which is what they did. 1d2 plus 2d1, or the derivative of the first, write down the second. The derivative of the second, write down the first. And then they set this equal to 0. Okay, so they got the exact, but they still got 5.77. And they still had the square root of 244.15, approximately 15 feet. All right, well, I think you get the idea. Write a couple equations, do the substitution. The important thing is just draw a nice picture and label it so that I can understand your process. I hope this video was helpful. Email me with your questions. Thanks.